So this is still 9.5. We're actually going to look at examples of how to do some problems now. Okay, so I'm going to look at number 2. Okay, first in 2, you want to graph and list the pertinent information. Okay, so for number 2, it is the problem y squared over 1 minus x squared over 9 equals 1. Okay, so we start with what's A, what's B, which way does it open? It's y squared minus x squared, which implies that it's vertical. Okay, A is equal to 3, B is equal to 1. So our c squared is equal to a squared plus b squared. 9 plus 1, or 10. So c is equal to the square root of 10. Okay, so if we've got our grid here, and we mark off left 3, up 1, right 1. Okay, we take this box and draw our box. We draw our asymptotes. Okay, and that last one was not very good. Let's try that again. Okay, and so we go through it like that. Okay, and it's vertical, so I'm right here, and I'm going that way, and that way, that way, and that way. Don't have to be too particular about where the points cross. Now we want to do the pertinent information, so let's go. Vertices. Vertices are up and down, so that's 0, B, so that's 0, 1, 0, negative 1. Covertices are 3, 0, negative 3, 0. Remember, the vertices are here, covertices are here. Okay, the foci, somewhere in that range there, a little over 3. So, 1, 2, let's put it here actually. That's your first foci. 2, and a little bit over 3. There's your other foci. So let's talk about where those foci are. They're on the vertical axis, so it's 0, and it's root 10. 0, negative root 10. And then your asymptotes, okay, well that's y is equal to positive b over a, 1/3 x, or negative b over a. Remember, it goes up 1, so from here we go up 1, right 3, and that's your slope of that line. From here we go down 1, right 3, so that's the slope of that line. Those are your asymptotes. We've graphed and found the pertinent information. Let's look at 6. Okay, 6 will be similar to one of your problems, right? And it's 4x squared minus 9y squared plus 36 is equal to 0. Again, we want to graph and find all the pertinent information. This is not in standard form, so let's rework it. 4x squared minus 9y squared equals negative 36. Need to divide by the negative 36. So I need 1 over there, so I get negative x squared over 9 plus y squared over 4 is equal to 1. And still not quite there because I need to move this. This has got the negative. We need to switch those things. And so I get y squared over 4 minus x squared over 9 is equal to 1. Okay, so again, this is a vertical. A is equal to 3. B is equal to 2. C squared is equal to 9 plus 4, which is equal to 13. So C is equal to the square root of 13. We need to graph it. So I'll come over here. I'll graph it. Okay, we go 1, 2, 3, 1, 2, 1, 2, 2, 3. Square root of 13 is slightly above 3. So make sure I have that. And so let's draw our box, which is too tall. Or from the center, and 3 left and right from the center. Asymptotes there and there. It opens up and down. so there is my graph. And if you want to put the focus, that's where one of the focuses are, that's the other one. So let's write the information. Vertices. Vertices are up and down, so that's 0, 2, 0, negative 2. Co-vertices are left and right, in this case 3, 0, negative 3, 0. Foci are 0, square root of 13, 0, negative square root of 13. And your asymptotes are y is equal to positive negative b over a 2 over 3x. Alright, so that's 6. Okay, so next example we'll look at is 14. It wants you to find the equation. Okay, and it's a hyperbola. They tell us it's a hyperbola, and they give us that the foci are positive negative 4, 0, and the difference of the focal radii, difference of the focal radii is 4. Okay, so that's again the difference in the focal radii. Okay, so this focal radii piece I haven't really talked about how it works, but the idea is if we know our focus are left and right 4, okay, left and right 4, then I know the distance from the box left to right, our vertices, is half of that. So A to A is equal to 4, so A is equal to 2. So, and I know C is equal to 4 because our foci are 4. So remember, C squared is equal to A squared plus B squared. So 16 is equal to 4 plus B squared. 12 is equal to B squared. So B is equal to the square root of 12, which we don't really need to know because we know it opens left and right. So I know it's x squared over A squared minus y squared over B squared equals 1. And I know A squared is 4, B squared is 12 equals 1. Alright, and so that's the answer they're looking for. Okay, we're going to look at 16 now. Again, 16 is find the equation, and this particular one tells us the asymptotes of y is equal to positive negative square root of 2 over x, and it tells us the foci are 0, positive negative root 6. Okay, so that tells us C is equal to the square root of 6. Okay, we know because the foci are here and here, we know it opens that way, so that tells us we're using y squared over b squared minus x squared over a squared equals 1. So if I know C, and now I've got to remember that my asymptotes are in the form b over a x. Okay, so what we want to do is we know b over a equals square root of 2 over 2. Okay, so that leads us to think b is square root of 2 and a is square root of 2. Okay, so we'll start with that and we'll check it. Remember, we want to make sure that c squared is equal to a squared plus b squared because this thing could be reduced in some form. Okay, so we want to make sure that works. And so we do that by doing, just plugging in here. Okay, so c squared, we got square root of 6 squared, and I think a is 2. I think square root of 2 is b, and so that tells me 6 is equal to 4 plus 2, and so that does work out. So we'll let this piece be equal to b, and this piece be equal to a, and so for my equation I get y squared over 2 minus x squared over 4 equals 1. Okay, and that works out for us. Alright, let's look at 18. 18 tells us we've got asymptotes y is equal to positive negative x, and we've got foci of positive negative 4, 0. Okay, so that tells us what? C is equal to 4. Since it's the x, we know it opens left and right. Okay, that tells us x squared over a squared minus y squared over b squared is equal to 1. And then I think it should work that y is equal to b over ax. And I have this as my asymptotes. So that's supposed to be equivalent to y is equal to 1 over 1x. So I check. B over A should be equal to 1 over 1, which leads me to think that B is A, or B is 1, A is 1, C is 4. So let's check that. So I want to do C squared is equal to A squared plus B squared. Okay, so that's 4 squared is equal to 1 squared plus 1 squared. And that is not true. Okay, so that's not true, so it's not 1 and not 1. So let's rewrite that, and let's say if I solve that, that says A is equal to B. Okay, so now I know C squared is equal to A squared plus A squared. Remember, if A equals B, then I can replace it there, and I get this over here. So now I have 4 squared is equal to 2A squared, or 16 is equal to 2A squared, or 8 is equal to A squared, which means A is equal to the square root of 8, which I don't really need to know because I need to know my equation. My equation is x squared over 8 minus y squared over 8 equals 1. That's my equation for 18. The problem I want to look at is 20. 20 is y squared is less than or equal to x squared minus 4. Y squared and x squared, if I simplify this, y squared minus x squared is less than or equal to negative 4. Starts to look like a parabola. Divide everything by negative 4. But remember, when you divide by negative 4, we get negative y squared over 4 plus x squared over 4. It flips the fraction, or flips the inequality. So, and then I want to write it in the appropriate form. X squared minus y squared over 4 is greater than or equal to 1. Okay, so let's get over here. A is equal to 2, B is equal to 2. Alright, so I do my box. Do my asymptotes. And that opens which way? It opens left and right because I've got x squared minus y squared. Okay, so it opens here and here. Okay, now, I didn't talk about this before, but it is greater than or equal to, so that means solid. Okay, and then I need to check. Where do I shade? I've got to shade. It's an inequality, so where do I shade? Let's go back and look at our original. It's here. I'm going to test a point. Okay, I'll test that point there, which is 0, 0. So I'm going to say is 0 squared less than or equal to 0 squared minus 4. That's false. How about I come over here and I test points left and right of this? Okay, so that's 2, so let's go like negative 4 and positive 4. So those are my x's. 0 squared is less than or equal to negative 4 squared minus 4. That's true. Or 0 squared is less than or equal to positive 4 squared minus 4. That's true. So I'm shading in the middle of these things right there. Okay, so remember it's inequality, so shaded, where do we shade, and is it opened or closed, dashed or solid lines?